Welcome to MRL. In this learning session, we'll be learning about whole numbers. The natural numbers along with 0 is a set of whole numbers. The whole number set is represented by a symbol W. W is equal to the braces. Within the braces 0, 1, 2, 3, 4, 5, 6 represents a set of whole numbers. The least whole number is 0, or the first whole number is 0. The greatest whole number is infinite. 0 is a notation for nothingness, and also 0 is a notation of a placeholder in a number which you already know. Natural numbers are a part of whole numbers. If you look at here, if you look at the set 1, 2, 3, 4, 5, 6 represents natural numbers, it's a part of whole numbers. N is therefore we say n is a subset of W, or n is a part of W, and this symbol is a symbol of subset. Now the next point of discussion is whole numbers number line. The whole numbers number line is a line which represents whole numbers, and for that we draw a horizontal line and mark the points A, B, C, D at equal distances, and if A represents 0, B represents 1, C represents 2, D 3, and so on. So please remember that. Now the next point of our discussion is the value of numbers. If you go along the number line, the value of numbers increase from 0 when moved towards right. 5 is greater than 4 because 5 is to the right of 4, 5 is on the right side of 4, 5 is successor of 4. 1 is less than 2 because 1 is on the left side of 2, and 1 is the predecessor of 2. So also 0 is the predecessor of 1, and 1 is greater than 0 because 1 is to the right of 0. And remember, 0 has a successor but 0 has no predecessor. Remember that. Now the next point of discussion is the operations on whole numbers, that is addition, subtraction, multiplication and division. We can add two whole numbers and get a whole number again, and we can subtract two whole numbers only if the first number is greater than the second, and again we get a whole number. And this can be shown using a number line. If you draw a number line, the addition of 3, that is 3 and 5, the 0 to 3 there is plus 3, and add plus 5, that becomes 8, and therefore plus 3 plus 5 is equal to plus 8. Now take 8 minus 5, jump to 8, then subtract minus 5, and that gives us 3, and that is how we can represent or indicate addition and subtraction of whole numbers by number line. Now multiplication of whole numbers. We can multiply two whole numbers, again we get a whole number. Multiplication is repeated addition, and therefore 2 into 3 is equal to 6 becomes 2 plus 2 plus 2 is equal to 6, and we also can represent it using a number line. 2 into 3 is equal to 6, jump 2, again 2, again 2, 2 plus 2 plus 2 becomes 6, therefore 2 into 3 is equal to 6, and that is how we can represent multiplication using a number line. Division of two whole numbers is again a whole number provided the 8 is greater than 2. Otherwise division is not possible for a set of whole numbers. Now what is division? Division is repeated subtraction. When I divide 8 by 2, it means that I am subtracting 2 from 8. 8 minus 2 is 6, 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0. I have gone 4 steps down, and therefore 8 divided by 2 is equal to 4, and that can be represented using a number line. From jump to 8, subtract 2 we get 6, subtract 2 we get 4, subtract 2 we get 2, subtract 2 we get 0. We have gone 4 steps to the left, and therefore 8 divided by 2 is equal to 4, and that is how we indicate the division by repeated subtraction on a number line. Now what are the properties closed for a set of whole numbers? As I have already told you, natural numbers is a subset of whole numbers. Therefore all the properties of natural numbers are closed for whole numbers, and of course you have learned natural numbers, but again I would like to repeat these properties which are closed for a set of whole numbers. Now let us take the closure property of addition. When we take two whole numbers 3 and 4, we add, we get 7. 7 is again a whole number. So 3 belongs to W, 4 belongs to W, 7 belongs to W. Therefore the sum of two whole numbers is again a whole number, the closure property of addition is closed, and it is true for any number A and B belonging to W. C also belongs to W. Therefore, closure property of addition is closed for a set of whole numbers. Now, closure property of multiplication, again it is closed for a set of whole numbers. We take two whole numbers, when we multiply, again we get a whole number. For example, when we multiply 3 and 4, 3 is a whole number, 4 is a whole number, 3 into 4 is 12, again a whole number, 0 is a whole number, 5 is a whole number, 0 into 5 is again a 0, that is a whole number. Therefore, for any A and B whole numbers, we get C, which is again a whole number. Therefore, closure property of multiplication is closed for a set of whole numbers. Now let us speak about the commutative property of addition. You all know what is commutative property. The order of addition of two numbers can be in any order, that is A can be added to B or B can be added to A. The answer is the same, or the result is the same. Therefore, when we take two whole numbers 3 and 4, we add, we get 7. Whether we add 4 to 3 or 3 to 4, we get 7. Therefore, commutative property of addition is closed for a set of whole numbers. Now similarly, commutative property of multiplication is also closed for a set of whole numbers. Therefore, two numbers can be added in any order in whole numbers, and two numbers can be multiplied in any order in whole numbers. Now coming to the associative property of addition, we know what is associative property already. That means the order of the grouping of numbers and adding in any order. That means A plus B plus C. B is added to A and then added to C. Here B plus C is added first, then added to A, we get the same answer. And to explain this in whole numbers, if you take 2 and 3 and 4 as whole numbers, 2 plus 3 gives us 5, and when we add to 4 we get 9. 3 plus 4 gives us 7, when we add to 2 we get 9. LHS is equal to RHS, and therefore the associative property of addition is closed for a set of whole numbers. Now similarly, associative property of multiplication is also closed for a set of whole numbers. That means, what is this associative property? When we multiply A and B and then to C, or B and C then to A, we get the same answer, that is LHS is equal to RHS. And to explain this with a set of whole numbers, take 2, 3 and 4, that is 3 whole numbers. 2 is a whole number, 3 is a whole number, multiply, we get 6, multiply by 4 we get 24, 3 into 4 is 12, 12 into 2 is 24, LHS is equal to RHS, and therefore the associative property of multiplication is closed for a set of whole numbers. Now let us talk about the distributive property. Now what is this distributive property? You already know it. A in the bracket B plus C gives us A into B plus A into C. This is distribution of multiplication or addition. So if you multiply if you find the LHS, then it will be equal to RHS. Now let us explain this using a set of whole numbers. 2 is a whole number, 3 is a whole number, 5 is a whole number. When we add 5 to 3, we get 8, and multiply by 2, we get 16. Then 2 into 3 is 6, 2 into 5 is 10, add them, we get 16. That means distributive property is possible for a set of whole numbers, and please remember that. Now when we take a whole number 5, multiply by 1, again we get by 5. Therefore we call this one is called as the multiplicative identity. It is very much true for a set of whole numbers, because 1 is a member or element of W, and therefore multiplicative identity is possible for a set of whole numbers. Now let us take the next property, that is additive identity. When we take a number 5 and add to 0, 0 is a whole number, 5 is also a whole number, again we get back 5, and therefore 0 is called as the additive identity. Additive identity, that is 0 is present in a set of whole numbers, and therefore additive identity is closed for a set of whole numbers and definitely not for natural numbers, because 0 is not an element of a set of natural numbers. So please remember that. So in all, the properties which are closed for W are 9 of them, and the properties are very useful in various mathematical operations. I'll just take an example here. Supposing if we want to multiply 8 into 69 into 125, we can apply the associative property, replace, then bring 125, make a group of that. 8 into 25 becomes 1000, multiply by 69 becomes 69,000, which is a very simple way of calculation using the properties. Now let us understand the operations with 0. Now 5 when added to 0, we get back 5. So 0 is the additive identity. It is a whole number. The additive identity is possible for a set of whole numbers. 0 is the only whole number having this property, and therefore, and also 0 is identity. Now when we add, when we multiply 0 to 5, we get 0. 5 into 0 is 0. Now how is that? Let us understand this by an example. 5 into 6 is 30. 5 into 5 is 25. That means it is 5 less. That means 30 minus 5 becomes 25. 5 into 4 is 20. Again 5 less. 5 into 3 is 15. Again 5 less. 5 into 2 is 10. Again 5 less. 5 into 1 is 5. Again 5 less. 5 into 0 has to be again 5 less, which is 0, and therefore 5 into 0 is equal to 0, which explains why 5 when multiplied by 0 is again 0. Please remember that. Now division of division of 0 by any number. When we take 0 and divide by 5, we should get 0. And how it is? See, 5 into 0 we have learnt here, it is 0. That means 0 is 0 divided by 5, and therefore 0 divided by 5 is equal to 0. A very simple explanation on the basis of the property of multiplication by 0, and therefore 5 when multiplied by 0 is 0. 0 when divided by 5 is again also 0. So any 0 divided by any number is again 0. Now division by 0. Division by 0 does not exist, because let us explain this. 5 divided by 0, if we apply because it is a repeated subtraction, so 5 divided by 0 is nothing. 5 minus 0 again remains 5. So when you continue, it is endless, undefined, and therefore 5 divided by 0 does not exist. It is not defined. Remember that. Now operations with 1. When we add 1 to 5, we get 6. 6 is the successor of 5. Understand, 6 is the successor of 5. So, or 6 is a consecutive number of 5. The next consecutive number of 5 is 6. So when we add 1 to any whole number, we get the next consecutive number. And one more very important thing, when we add 1 to an odd number, we get an even number. And when we add 1 to an even number, we get an odd number. Whether it is 5 or 6 or 7, they are consecutive numbers, or consecutive whole numbers rather. Now let us understand the multiplication of 1. Multiplication of a number by 1 is the number itself. That means when I multiply 6 into 1, I get 6, and 1 is the multiplicative identity, very much true or possible in a set of whole numbers. When you divide any number by 1, again we get the same number, because 6 into 1 is 6, 6 divided by 1 is 6 again. So please remember this, division by 1 is again the same number itself, and multiplication of a number by 1 is again the number itself. Now division of 1 by any number. Division of 1 by any number is 1 by 6. For example, 1 by 6 does not exist for for a set of whole numbers, and therefore it is not closed for a set of whole numbers. Now some important properties. If A, B and C are whole numbers, A divided by is equal to C. If A divided by is equal to C, it implies that B into C is equal to A. Please understand this. If A divided by is equal to C, then it implies B into C is equal to A. Also, if B into C is equal to A, it implies that A by C is equal to B, or A by B is equal to C. A simple mathematical operation. So, for one multiplication statement, we have two or division statements.